Thank you. I want to welcome everybody to today's webinar. We'll be covering three-dimensional fires and a few other things. We'll be talking about some of the foams and some of the other techniques as we go through. And at the end, we'll have some, of course, be able to answer some questions for you. To start with, to give you a little bit of information, we'd like to let everybody know that hazard control technology, our mission is to be a leader in fire prevention, protection, suppression, and we're very proud of the fact that we offer innovative, environmentally friendly solutions, as you will see as we go through the presentation. Our headquarters are based in Atlanta area, Fayetteville, Georgia. We are a global company with distribution worldwide. Again, we started in 1997, and testing has proven while we're looking for solutions for fluorinated foams, as we go through, we'll see some of the problems and advantages when you look at encapsulator technology. Some of the organizations that we are members of, NFPA, we also have members of hazard control technologies that sit on some of the tech committees. We're ISTA contributors, as well as working with the Society of Fire Protection Engineers. Another thing that we're very proud of is the fact that we're an ISO 9001 registered company. Customer and quality control is very, very important and number one top priority of our company. When we sit there, we start looking at some of the hazards that as firefighters and industry we're faced with. You know, we sit there and we oftentimes hear about the lithium-ion batteries. Again, as this program will cover the three-dimensional fires, we start looking at our Class D metals, our magnesium and the titanium fires, as well as solar panels. Again, solar panels are going to be a source that as long as it's sunny, you can't shut off that supply of energy. So we'll talk about a little of those, but again, we're going to key on that three-dimensional aspect. So some of the things that we're going to cover today, we do with pretty much all of our trainings, but we look at that chemistry of fire. We'll talk about the encapsulator technology, the features, the applications, and then we'll look at those three-dimensional fire applications and then some of the equipment that we offer. So our objectives is to understand, you know, what a three-dimensional fire is and the differences, why foam doesn't work on them, and why and how an encapsulator can extinguish these fires. We'll explain the characteristics, and again, we'll talk a little bit about proper application, and then we'll identify some of the industries where these encapsulator agents can be used. So to start with, we'll need to learn a little bit about our chemistry that we learned when we were in basically our fire schools or going classes learning about it. And we look at that, basically our fire tetrahedron.
The old and familiar representation of a fire triangle has been replaced with a fire tetrahedron because we now know and recognize a fourth element crucial to combustion, a chemical chain reaction. The four sides of a tetrahedron represent the four components of fire: heat, fuel, oxidizing agent, and the chemical chain reaction. If any one or more of these components are absent, a fire cannot occur. When all four components are present, heat, fuel, oxidizing agent, and the chemical chain reaction, fire will occur. There are four options for extinguishment: cut off oxygen, cut off fuel supply, thermal insulation of the fuel, and interruption of the chemical chain reaction. When one or more of the components are removed, the flame goes out.
So as we proceed with this, we're going to see how foams are causing that separation of the oxygen and the fuel, and then how an encapsulator agent works on multiple sides of that triangle, being a much more effective and efficient way to extinguish and control some of the difficult fires. So where water, we use steam conversion to help us extinguish fires. When we sit there and we start looking at foams create a blanket. And as we always say, what do you do at night when you want to, or you're getting cold. You pull a blanket up to keep the heat in. So again, it's not a good source to cool. It causes that separation between the heat, the oxygen, and the fuel. And if you're not there to continually reapply foam until we get down below that auto ignition temperature, you have everything you need once that blanket basically breaks down or runs off to have a fire reignite. Or when we sit there and we start looking as we go through and talk a little bit more, we're going to see how with an encapsulator agent, you're going to get that rapid and permanent heat reduction. The encapsulation of those hydrocarbons, both polar and non-polar solvents, and hydrocarbons, interruption of that free radical coalescence, and then all the different types of fires in that 3D category that we're able to work on. So when we look at the standards, NFPA, when we look at 18, a wetting agent standard, we're making water droplets smaller. Being able to get in smaller areas, reducing the surface tension of water, creating more steam. Again, we talk foam, thin wall bubble structures, fragile. They can, be affected by heat and wind. And when we sit there, we start looking at an encapsulator agent. Now we're looking at spherical micelles. And when we talk about the spherical micelles as we go on, you'll see how it is so much different, where the thin wall bubbles work on a mechanical basis. You're looking at the encapsulator agents working on a chemical molecular basis. To start with, and to help us better understand why foam doesn't work on those three-dimensional fires, we need to just go to NFPA 11 and look in Annex A11. And within that standard, it even states foam is not suitable for a three-dimensional flowing liquid, fuel, or gas fire. So even in the standards, they recognize the fact that for all these years, we've been using foam on fires it's not designed to be used for. Now we can sit there and we can look at, like I say, some of our encapsulator agents and why they work. Encapsulator agents fall under a different standard, NFPA 18A, which is the standard on water additives for fire control and vapor mitigation. And within that standard, you're going to see that it covers many classes of fires. I mean, rather than having different types of extinguishing agents for, different fires, now you're looking at one agent that can work on multiple classes of fires, including that 3D category of fire. Within the standard is a spherical micelle stability test, which is covered under section 7.7 of the standard. It covers, class A fires, class B fires, but the thing is to understand that test and, how those spherical micelles work. So the building block, as we said, of the encapsulator agent is a spherical micelle, and they're able to encapsulate both carbon, hydrocarbon molecules, and we're talking in polar and non-polar. So it works on the alcohol fires as well as your hydrocarbon fires. Another advantage is when we talk about foams do not work on vapors. Here you see that a spherical micelle is also effective not only on liquids, but on vapor molecules. Again, a great advantage when you sit there and start looking at some of our three-dimensional type of fires. It also separates fuel from the oxygen, as I said earlier, on a chemical molecular basis. So to help us understand
encapsulator technology, the next generation of fire and hazard mitigation. First, we start with a simplified version of a single encapsulator agent molecule consisting of a hydrophilic polar head which loves water, dissolves in water, and a hydrophobic non-polar tail which fears water and will do anything to get away from water. Once the EA molecules enter the water, they instantaneously and automatically orient with the non-polar tails inward and the polar heads outward, forming millions of spherical micelles. Micelles travel towards and exit the nozzles, forming EA droplets. Micelles nearest to the surface of each droplet automatically break apart. The nonpolar tails orient outside the droplet with polar heads on the surface, forming an EA skin on the surface of every droplet. In addition to the EA skin, there are millions of molecular spherical micelles within each droplet.
So that's a real quick animation showing you how a spherical
Encapsulator
how it
technology.
works. To give you an idea of the size of those spherical micelles within a water droplet, is if we were to imagine a water droplet as being the size of the Earth, those spherical micelles within the water droplet would be the size of a pea. So as give sort of a visual on how many of those micelles are within each water droplet. And again, that is where we're getting that encapsulation ability to deal with the flammable liquids and gases. The other advantage is that when you start using this on hot surfaces, where in the past with water we've seen steam, now you've got a mechanism to rapidly cool and extinguish without generating steam. And we'll see that here as we go on. So unlike foams, an encapsulator agent is going to give you some rapid cooling abilities, encapsulation. We look at that interruption of the free radical coalescence where the toxins, we're able to reduce those, and again, the fluorine free. So when we talk about those spherical micelles within the droplet, we talk about them being a thermal circuit, because what we're doing is we're driving the heat interior to the water droplet. And what's happened is all those spherical micelles that are inside the water droplet rapidly absorb the heat and then slowly release it into the water around it. So that's why we do not generate steam. To show you some of the abilities and how quickly it's able to cool and
Hazard Control Technologies presents F500 encapsulator technology. This demonstration at a large metal recycling facility shows an old car hood being heated with an acetylene torch. The high temperature causes the paint on the front of the hood to catch fire.
You'll see here in
a thermal imaging camera shows the increase in temperature, but the camera only shows temperatures up to 1238 degrees Fahrenheit. The actual temperature is well above 1238. As the 3% F500EA solution is applied from a 2.5 gallon fire extinguisher, watch how fast the temperature drops. Also, notice the fire quickly goes out. Remove the heat, extinguish the fire. The F500 encapsulator agent never touches the fire. Simply removing the heat is enough for extinguishment. Foam has one method of extinguishing a fire, by smothering it, but the blanket of foam traps in the heat, often causing reignition. And since it needs to make a blanket of foam, an FP11.
So as you can see, he was able to really quickly, just from hitting that on the back, drop those temperatures down below 100 degrees in a matter of seconds, to where he could now put his hand on the surface of that metal hood without burning. So when we sit there and start looking at, again, a little bit further on as we go through the program, let's think about and watch some of these metal surfaces that we're dealing with that could be a heat source for reignition. So when we sit there and start, again, looking at the encapsulation properties of the F500 and how it's able to reduce drastically the reignition hazards, we're getting in and we're going to talk about that 7-7 spherical micelle stability test. And to understand it, we need to know that there is a formula that is used that to help us identify or help us understand just exactly how much fuel we're able to encapsulate. And that formula is 1 part of F500 concentrate, 8 parts of fuel, 40 parts water, or a 1-to-5 ratio. And then kinetic energy. So the kinetic energy would be those water droplets with the F500 solution hitting the surface of the ground, or as it's coming in contact with those flammable vapors in the air. This is a quick video to show you that stability.
Here we're demonstrating the NFPA 18A Section 7.7 Spherical Micelle Stability Test. In that test, you take your test fuel, which could be any fuel, in this case gasoline, it could be heptane, alcohol, ethanol, and we're pouring in 1 gallon of the fuel into the test pan. We pour all the fuel in, and then we mix in 16 ounces of the encapsulator agent being tested. And here, using a calibrated 5 gallon per minute nozzle, we're going to add 5 gallons into this mixture. So basically we're going to add water for 1 minute. We're going to mix it around and agitate the mixture and move all around. This test is testing the ability of an agent to develop and maintain stable spherical micelles in the presence of high heat. We're adding the water for a total of 1 minute, which will represent 5 gallons. Now the test calls for for 1 minute, and then we come by and we will apply a heat source to the top of the surface of this mixture. We should not have any ignition. After 1 minute, we can see we have a heat here. We apply this to the top surface of the mixture, go all around. We shouldn't see any flammability. Here, just to demonstrate that we have a torch. You can see we're evaporating water off the pavement. And when we increase the heat, she'll go. And now we will come back after 2 hours and redo the ignition test. And after 2 hours, this cannot ignite. Thus, it proves that we have created stable spherical micelles, and they remain stable over a long period of time in the presence of high heat. Applying the flame over the entire surface of the pan, and you can see we have no ignition after 2 hours. If this were a wetting agent that doesn't form spherical micelles or a blanket, then we would have had ignition at the 1 minute test and all the fuel would have burned off. If this was a foam, it probably would have formed a foam blanket. We may have passed the 1 minute test because we have a blanket, but 2 hours later, all the bubbles would have dissipated and you would end up with ignition after 2 hours. So what this test is showing you is this agent creates, forms, and maintains stable spherical micelles that can encapsulate the fuel, thus separating the fuel from the oxygen, and those micelles are stable at a very high heat environment.
So that gives you a little bit hopefully a better understanding of those spherical micelles, how they work, and the test to find out if the product is truly an encapsulator agent. That is covered in 18A, that section 7.7 test. So now that we understand how those micelles are tested in the presence of high heat, we'll talk a little bit now about the encapsulation, the ability of the encapsulator agents to reduce the toxins, including your hydrogen fluorides, which we're going to find if you've been to some of our other webinars where we've talked about lithium ion batteries. That hydrogen fluoride gas is one of the hazards that we encounter when we sit there, we deal with those types of fires. And to understand, this is results from some testing that was done by Clemson University on the abilities of an encapsulator agent, or just exactly what an encapsulator is doing. And what they did is they used an inverted glass funnel test using toluene as their source of burning material. And they were looking at three things. They were looking at the light transmission through the smoke column. They were looking for the accumulation of soot on the walls of the inverted funnel, and then the toxicity of that soot and smoke. So they ran their test using water, and then they repeated the test using a 3% solution of F500. And the results were, they noticed that without adding any ventilation, there was a 68% increase in visibility. The amount of soot on the walls was reduced by 97%. But when we look at, cancer in the fire service, and we keep hearing about all the issues, right here, soot and smoke toxicity was reduced by 98.6%. I mean, it's huge. It's a huge benefit, and a way that we can sit there and make some of these fires that we are called to safer, especially when we start dealing with industry and chemical plants. But because of all of the new synthetic fibers and materials that we're seeing in our building construction, much quicker buildings and things are burning. Again, this is a great way to protect not only ourselves, but also possible victims that may be within those homes that we're going to fight the fires. One of the other things when we sit there and start talking about, again, our foams is, as we've all seen, if we are following, or for firefighters, or if we are doing anything as far as following some of the issues behind our foams, is the PFOS and the PFOAs. The issues from past use, and even, some of the hazards that we are possibly facing moving forward. This is, still, an issue that we are learning about more and more each day as areas where there were military bases, especially Air Force or naval bases, where they've tested and trained with foams. It's a hazard. Now, when we talk about an encapsulator agent, an F500, it's non-corrosive. It's non-hazardous. It is fluorine free, and we've had it tested to the EPA modified 537 test, which tested for 25 different fluorinated ingredients. The results were that there was 0 detectable fluorine of the 25 tested for. The product is 100% biodegradable. And when we talk about spill control and surface washing and things like that, we are on the EPA's National Contingency Plan and listed as a surface washing agent for those purposes. So to cover a little bit more about those foams and the health hazards, I'm going to go through this section kind of quickly. I put these slides in here because there are links to some really, really good articles about the PFOS and the PFOA hazards. As Hernan said earlier, he's recording this, that he can email and share this presentation with everybody, which is why he's asked that you put your email or your names in there so we can get this out to you. But some of these links, I'm going to go through them, just breeze through them real quick. Again, they're going to be hyperlinks that when you get this program, you can kind of go through it and click on those hyperlinks, and hopefully they'll work and take you to those articles. But when we sit there and we start looking at the PFOs and the problems, I mean, we look at, all these different regulations around the world that are coming out, banning their use. and really restricting them because of the fact that, you know, they're bioaccumulative. Once they get into your system, your body, okay, you don't release them. Each time you get exposed to them, you know, there's more and more that your body holds. The problem is while we hear about the cancer in our trade magazines, there's a lot more health effects than that cancer. So again, many of these articles and some of these that you'll see are going to be hopefully informative and give you some better idea of just how big an issue this is worldwide. But again, you'll see, you know, we're talking not only the United States, but we're looking at Australia, New Zealand. Again, these are some of the hyperlinks that I'll show you where it talks about the health effects and the articles on firefighting foam. You know, military bases, many of them. I can name a couple where, you know, the Cannon Air Force Base, there's a dairy farm, Clovis Dairy Farm in the near proximity, where all the milk each day is destroyed because, again, the cows are drinking contaminated water, so they can't sell the milk. You have air bases and places like Michigan, where there was not only used with the foams, but also in some applications with auto industry or some of the others that, you know, have affected areas big time within the state of Michigan. And you can see there's this map. It's a map. You can click on it. It's interactive. That'll highlight all the areas that are really hot spots and known to have drinking water effects. But anyway, these, again, hyperlinks, feel free. I mean, take some time, read them. They cover all the different areas. I've read not all of them, but I've gotten through a few of them, but there's some good information if you want to learn more about those surfactants and the effects on the body, all the effects, not just the cancer. So getting out of that, let's start talking about some of the applications when we look at your encapsulator agents and how we do it. One of the first things I want to do is give you a little bit better introduction.
Hazard Control Technologies presents F500 encapsulator technology.
One of the things I'll point out is if you look off to the left, we have listed all classes of fires: Class A, Class B, and watching the video, black smoke is going to turn white. That's that interruption of the free radical, those carcinogens, toxins. No steam, you see a warm white mist. We got some videos from people that talk about that being no hotter than a shower. When you look around on the ground, you don't see excessive amounts of water. When you look at this, foam has 3 application techniques. When you watch these videos, you really don't see them having any special technique other than aggressively trying to extinguish that fire. Here's a 3-dimensional thing. Makeup of a jet engine cover. FA11 again. Videos. You want to search Google and YouTube and look at engine fires, aircraft engine fires. You'll see ARC trucks, difficulty extinguishing these fires. Lithium-ion battery energy storage, sources. We always hear there's no solution yet. We're able to extinguish that battery and stop the Class 2 metals. No explosions. Able to control the heat and extinguish those Class 2 metals.
Okay, can you download the sound, please?
Okay. It's hard to tell. It's not loud on my end. Sorry.
Thank you. We want to
Sorry.
listen to you, not the music.
Yeah. It's hard to tell the sound, how loud it is. Sorry about that. And then the last one was a transformer. When we looked at that transformer, I want to make a mention that you didn't see any arcing or sparking from that transformer. That transformer had failed. It was now a oil fire or a Class B fire, in a Class C environment. So you can have a better understanding of how it worked there. Yeah. So let's get in now and talk and discuss a little bit more of the three-dimensional applications. You know, we sit there and we start looking at all the different applications. We can look at, you know, the fire protection as far as in the power industry, our under turbine lube oil systems, you know, our transformer protection. We can look at tank truck loading facilities, even, you know, where they offload possibly, tank farms, pipelines, manifolds. I can sit there and we can talk about some of the fires at these tank farms. In many cases, they'll may start with a leaky valve or a flange, or again, most recently, Deer Park, Texas, was a manifold. Three-dimensional fire that, you know, had an encapsulator agent been used, may have been able to prevent many of the tank. They lost 11 out of 15. So when we sit there and start looking at these three-dimensional fires, and yeah, a tank truck would be considered a three-dimensional fire. We sit there and we watch, you know, foam application. Looks like they're doing a pretty good job. You know, it looks like a decent foam blanket. However, when we sit there and we start watching what happens, foam is not designed to put that three-dimensional fire out. When we also look at foam, we want to make sure we have the proper applications, make those bubbles. So we use aerated, aspirated nozzles. And sometimes we have to get up close, and that's not always the best idea as well. As you can see, you know, the foam is not very effective when it starts getting into the Class D metals. The three-dimensional aspects, while they seem to be making a really, really good blanket, you can't put that three-dimensional aspect of this fire out. You know, as long as there's fuel flowing, there's fuel running, you're not going to have it. Another great example is an industrial fire inside of a structure. Foam was being used to try to extinguish the fire, and now the fire is basically floating outside the structure on top of the foam, and we just lost ourselves about $1 million fire apparatus. Not because it was in the wrong place, it was just we're using the wrong product to try to fight a three-dimensional fire. So hopefully we can get a better understanding of these three-dimensional fires, the difficulties of them. And when we sit there, we start looking at some of the training. Here's a good one where, again, when I mentioned those three application techniques, it's rain it down, bank it in, or roll it on. You're looking, they're using what seems to me like that rain it down pattern here. They're not building the blanket up in front and trying to push it on. So they're raining it down. They do have a metal structure in the back that they could bank it in with. But again, he's using that rain it down method. Now, as he's going through and he's doing this, you can see how slow, I guess you can say, he is to be able to try to get this fire to extinguish. And when we sit there, we start watching or learning and reading more about some of the three-dimensional trainings that go on. They always talk about dual agents, using a dry powder. And here they're showing that example. Here they're trying to fight the fire while foam is maybe having some difficulties or not responding real quick. They sit there and they start using that dry powder. Many cases, Purple K, if we want to get to product specific, but you know, they use these dry chemicals to assist. And in the next video, you'll see as well, just we sit there, we start looking at this particular video, we'll see that they're using the water to cool the metal. They're trying to cool the steel. That's a reignition source. But they can't put that three-dimensional aspect of the fire out, so they use that dry powder. The dry powder is able to help them extinguish by breaking that oxygen fuel connection, and then they continue to flow the water so they can keep that structure cool. But look how many hand lines we have going on here. We've got, you know, three that are pretty much directly on that column trying to fight that fire, as well as the dual agents. Now when we sit there with an encapsulator agent, we're going to go through a video here and we're going to see some of our 3D abilities, a distillation column, similar to what you just saw. One hand line with a 3% mix of encapsulator agent. Here we're getting into what would be like an oil well blow off. How many hand lines? One hand line. Very effective. Being able to cool, being able to extinguish, being able to rapidly knock the fire down. No special application technique. The jet engine column. Again, we're going to see they don't shut the fuel off. The fuel is going to be running all the way till the end. The only application, or the only thing that you can make a note about, is watch the person on the hand line. He's changing his spray pattern on the nozzle. He's working to do two things: cool that metal, as well as encapsulate and extinguish the fire. When we talk about the valves and the flanges, the manifolds, and some of our petroleum situations, tank farms, oil farms, tank refilling stations. Again, difficult fires, foam can't extinguish them. Here we're going again with one hand line. We're able to rapidly extinguish that fire. One hand line. Some testing that was done in Brazil. But again, this is just a wide range of different types of situations where an encapsulator agent is very effective in being able to extinguish and control these fires. It's rapidly able to cool that metal to stop reignition and extinguish these fires. So we start looking for solutions to how are we going to do these fires. Here it is.
Hazard Control Technologies presents F500 encapsulator technology. Refinery Milazzo in Taranto, Italy witnessed testing of F500 encapsulator agent conducted by the Italian Navy, but were concerned the test devised by the Navy may not accurately reflect the hazards in a refinery. Among the tests they chose for demonstration was this three-dimensional, pressurized, flowing diesel fuel fire. The fuel was ignited in the 7 by 10 foot pan. The inclined metal plane was allowed to build up heat. Notice the flowing diesel fuel continues to flow throughout the exercise. NFPA 11 Annex A 11 states foam is not suitable for three-dimensional flowing liquid fuel fires or for gas fires. This is where F500EA excels.
So again, I'm going to point out, no special application other than aggressively trying to extinguish the fire.
Encapsulates the fuel, rendering it non-flammable, and cools the metal and fuel below the auto-ignition temperature. Remove the heat, remove the fire. At the same time, F500EA interrupts the free radical chain reaction, which reduces the smoke and toxins, turning the black smoke into a harmless white vapor. The fire was extinguished in 35 seconds.
So you know, those last couple of videos were some really good videos to show you just the advantages and just how effective an encapsulator agent is without having to require a special application technique. Here's a good side-by-side, because I know there's many times when people say, oh, you know, turn that one down a little bit. But this is a good side-by-side comparison showing foam and an encapsulator agent. There's no talking in that one, so I'll shut the volume off so you don't have to listen.
Yes, it's very loud.
Yeah.
Without sound, please. Thank you.
So you can see on this one, you know, the foam. Again, they're going to be using, you know, a couple of nozzles here trying to cool. They're going to be coming in with the air aspirated foam nozzle with the F500, the encapsulator agent, you know, very quick knockdown on that three-dimensional aspect, the fire, rapid extinguishing, cooling the metal, no reignition. And when we sit there and start going at the other with the foam, you'll see the difficulties. You see that stream flowing down the side of the tank. The foam is having absolutely zero effect on that stream. So this is a really good video just to show how ineffective the foam is on those three-dimensional fires. I mean, here he is, he's, getting the foam right there at the seat of the fire, but yet you have that one string of fire, that liquid trail coming down, and the foam has zero effect on that being able to extinguish it. So that's a really good video to help, again, show how foams are not effective when we deal with them. So when we start looking at some of the methods, again, with an F500, an encapsulator agent, we're not relying on those bubbles. So when we sit there and start getting into the windy days, let's say you have some type of an outdoor fire involving, a fuel source where wind and rain may affect your bubbles as far as blowing them and making them harder to direct your streams onto those fires, or, the rain's going to destroy your blanket or your bubbles as fast as you're trying to apply them. When you sit there and you look at an encapsulator agent, we rely on the water, the bubble, or I should say we rely on the droplets, not bubbles. So we can go longer distances, be less affected by that wind and not affected at all by the rain. And some of the delivery methods would be this turbo cannon. And then, like I said, we have some response trailers. Here's an example of one response trailer that's got a tote with a couple of monitors on it. I have another one. But when we sit there and look at these solutions, we can use these in what we call our concentrate control systems to protect pipelines and manifolds, valves at various facilities, our truck loading racks, flammable combustible liquid storage areas. We've got, again, as you saw, the turbo cannon, the trailers, compressed air systems. And when we look at the three-dimensional aspects, you've got the, using the 3% F500 mix. We've got the F500 EA VEEP system. And as I pointed out in the last few videos, there's no special application techniques like with foams. So to really quickly kind of summarize and get to some of the end here and get ready to start answering some questions, we're looking at a very unique suppression agent that's, again, has the abilities to encapsulate those carbon, hydrocarbon molecules, polar solvents, and some testing has even shown that we're able to neutralize acids, cancer, and some of the things that we're being exposed to in some of these fires, especially when we start going to some of our chemical plants. We're looking at the ability to reduce some of those cancer-causing toxins and things that we're exposed to. And now we have an agent that hopefully you have a better understanding of how it not only works on the 2D fire, but on those 3D fires, those difficult fires, the ones that are a little harder to put out. And again, as I've mentioned all through, and we've shown, foams can't extinguish. The product works in fixed suppression systems. So when we talked about those concentrate control systems, we do work in those, and we are able to work in applications where you may have high voltage. We've got testing that's been done. So again, just to cover some of the equipment, as you can see here on the right is a little bit of our VEEP system. When we talk about the concentrate control systems, you'll see top left there, you got the tank, the concentrate control tank, which can then lead to manifolds and protect various areas of a facility, under turbine lube oil, transformers, pipes, valves, manifolds. And when you sit there and you look at the bottom one, this is an example of a system where they're using a water-driven proportioner. And again, all the risers to the different areas of the facility or the plant. And when we start talking about lithium-ion batteries, charging stations, I mean, we're looking at more and more of these applications that companies are going to high-lows. We've got lithium-ion charging stations going in parking structures or parking lots at our local Walmarts or some of our other shopping centers. So when we sit there if we're looking with some of our fire codes and standards for solutions, your encapsulator agent's going to be a great advantage. Again, another example of a trailer. This one holds about 500 gallons with a monitor and some pre-connects on it. So various ways that we can configure things and help out and meet your needs. So we got the fire extinguishers. We've got our quick attack mobile units that you'll see up here in the top right of the screen. And the portable carts, the yellow carts there, and the 100 and 150 liter, and then the compressed air systems with 10, 30, and 60 gallon, and then some of the other equipment. As far as the consulting and training, we do the emergency response planning. We can help with annual concentrate testing, inspection and certifications of those sprinkler systems, those fire protection systems. And one of the areas that we're starting to see more is some of the dust hazard analysis, as far as training courses. Some of the modern day car fires, especially with all the hybrid vehicles, and you start talking about solar panels and energy storage systems, those lithium ion batteries. So we can sit there and we can hopefully help out and give some assistance and some training in other areas that you would like to get some information and have a better understanding of how encapsulator agent works on those types of fires as well. And with that, we can open up the floor to some questions.